Welcome. Principle and applications of infrared spectroscopy. If you are new on this channel, please subscribe it to see new videos. It also motivates me to create more content for you. Now, question is that what is the IR spectroscopy? IR spectroscopy studies the interactions between infrared radiation and matter. Now question is that what is the IR radiation? IR radiation is electromagnetic radiation and its range is 12,800 to 10 cm inverse, and it can be divided into near infrared region, mid infrared region, and far infrared region. To discuss IR spectroscopy, we will usually mid infrared region. How does infrared radiation interact with the sample? Due to internal electronic rearrangement, atoms in the molecule don't remain fixed at their positions but continuously vibrate at a specific frequency and produce the IR radiation. When electrons in a bond come nearer to each other, then repulsion takes place. When they go far away from each other, then attraction takes place. Due to such type of repulsion and attraction, that is electronic rearrangement, atoms in a molecule don't remain at fixed position but continuously vibrate. That vibrational frequency fall in the IR range. When IR radiation passes through the sample, it triggers vibration of specific molecular bonds, and a specific frequency of the IR radiation are absorbed. The absorbed specific frequencies are missing from the transmitted light. The missing frequency of IR radiation give a lot of structural information of the molecule. The absorbed frequency may lead to symmetric stretching, anti-symmetric stretching, and bending like vibration in the molecule. There are also other vibrations like rocking, twisting, and wagging. Different types of bonds, for example, double or triple bond, and bonds with different atoms like carbon-oxygen bond, carbon-hydrogen bond, carbon-nitrogen bond, etc. each have a specific vibrational frequencies. Thus, transmitted light carries a lot of molecular information of the sample. IR spectrophotometer uses that transmitted light to get IR spectrum, and IR spectrum gives a lot of molecular information. Now question is that how IR spectrum can be obtained using transmitted light. Nowadays, Fourier transform interferometer is used to get IR spectrum. It contains Michelson interferometer. Michelson interferometer contains IR source, beam splitter, fixed mirror, rotating mirror, sample compartment, and detectors. IR radiation come from IR source and fall on beam splitter. Beam splitter splits the IR radiation into two parts. One part goes to fixed mirror and second part goes to moving mirror. Light from the fixed mirror again reflect and transmit through beam splitter. Light from moving mirror again reflects and come on beam splitter and again reflects. Here both light combine together and start the journey and fall on the sample. Detector detect the transmitted light. Detector detect it and convert into raw signal, which is plot of mirror position and light intensity. This is called interferogram. This raw signal or interferogram is mathematically Fourier transformed to get IR spectrum, which is plot of transmittance versus wave number. It gives a lot of information. Now question is that what is the procedure to performing the IR? First, blank is run, then after IR of standard sample is performed. After that, IR of sample is performed. Then sample IR spectrum is compared with the standard IR spectrum to check the identification of the sample. Now question is that how functional groups can be identified by IR. The answer is that different functional groups gives peak at different wave number and hence different functional groups are identified by IR. For example, this compound contains OH group, NH functional group and carbonyl functional group. The peak at 1644 is due to carbonyl group. The peak at 1611 and 1564 is due to carbon-carbon double bond of the aromatic ring. The peak at 3161 is due to OH group. The peak at 3325 wave number is due to NH group. IR spectrophotometer is used for both qualitative and quantitative analysis. It is like a chemical fingerprint, as thumb impression of two different persons cannot be matched. In the same way, IR spectrum of two different molecules cannot be matched. It is used in different industries like pharmaceutical industries, food industries, pesticide industries, polymer industries. Thank you. Any questions related to this lecture, write in the comment section and I will answer on priority basis. To enhance more knowledge, watch my next video, which is on application of IR spectrophotometer in pharmaceutical industry.